Hello students, Mr. Madison here, and I'm going to do a video key for you on practice 1, area of circles. This is our first practice involving finding the area of circles or the area of parts of circles. We have 9 problems. I'm going to run through them and explain how to do them. Let me remind you that the formula for the area of a circle is pi r squared. And I'd also like to remind you that I gave you this problem-solving tool where you make a little table. And in the table, you have 4 columns: radius, diameter, circumference, and area. And the reason this tool is valuable is because you never know when you do a problem what piece of information you're going to be given. You might be given any one of these 4. And you never know what piece you're going to be asked to find. So you could be asked to find any one of those 4. So let's look at the situation here. This circle represents a circular pond, and there's fish in there. Koi, if you are unaware, are a type of fish. Just think like a big goldfish. And it says that the area of the pond is 225 pi square feet. So in my table here, in the area column, I'm going to go ahead and put 225 pi. And I'm going to fill in the rest of the table. Well, I know that this 225 is what you would get if you square the radius, because our formula is pi r squared. So to figure out what r is, I'd have to take the square root of 225, which is 15. And that would make the diameter 30, and it would make the circumference 30 pi. So now I know all about my circle. I know the radius, I know the diameter, I know the circumference, and then the area was given. It says a fence is to be constructed around the edge of the pond. So a fence is going to go all the way around the edge of the pond. Maybe not so much to keep the fish in as to keep people out or somebody from falling into the pond or stepping into the pond. But anyway, we're going to put a fence around the circumference here. How long is the fence? So this question is asking you to find the circumference. When it asks you how long is the fence that you'd have to construct to go around this circle, it's really asking you for the circumference. And it says round the answer to the nearest 0.01 foot. So here's my answer right here, 30 pi. But I'm just going to take that 30 and multiply by pi on my calculator, hitting my pi button, and I'm coming up with 94.247. And it says round to the nearest 0.01. So my final answer then is going to be 94.25 feet for problem number 1. Problem number 2, we have a circular rose garden. And it says the circumference of this rose garden, the distance around, is 48 pi feet. So here's what I'm going to do. I'm going to make my little table again. Radius, diameter, circumference, and area. And in this problem, I am given the value for C. It says the circumference is 48 pi. And I'm just going to go ahead and fill in the table. That would mean that the diameter is 48, and the radius would be half of that, 24. And the area would be, using my formula, pi r squared, so I got to square 24, is 576 pi. So that's the area. It says, what is the area of the garden? Round answer to 0.01 feet. So 576 pi is the area, but I'm going to take 576 and multiply by pi, and I'm coming up with 1809.557. And I need to round this to the nearest 0.01 square foot. So my final answer for problem number 2 would be 1,000 809.56 square feet. There we go. All right. In number 3, we are constructing a helipad, which is a circle, and it's made out of concrete, and the thickness of the concrete is going to be 6 inches. The problem says that if concrete costs $116.50 per cubic yard, what is the cost of the concrete to build this helipad? Okay, we have to be real careful with units. I'm going to write down the formula for the volume of a cylinder. The volume of a cylinder would be pi times the radius squared times the height. But when we plug our values in here for R and H, we want to plug them in as yards because the price is given per cubic yard. So I've got 75 feet here. So 75 feet is the diameter. 75 feet is the diameter. So let's think about this. That would mean that the radius would be half of that. So the radius then, if I take 75 and I divide by 2, then I'm going to find the radius here is equal to 37.5 feet. Now, when I want to change feet into yards, what I would do is I would divide by 3. So for the radius then, in yards, I'm going to have 37.5, and then I'm going to put that over 3, and that's what's going to get squared. That fraction, 37.5 divided by 3, is the value for your radius in yards, and that's going to get squared. And then the height is the thickness of the pad. And the thickness of the pad is given to you as 6 inches. So when I want to change 6 inches into yards, I need to divide by 36 inches in a yard. So my height then would be times 6 over 36. All right, now it's time to go to the calculator here. I'll tell you what I'm going to do in my calculator as I key it in. I know that 37.5 over 3 squared is the same thing as 37.5 over 3 times 37.5 over 3. So I think I'm just going to do that. So first thing I'm going to do is put in pi. So now I got pi, and I'm going to go times 37.5 times 37.5 times 6. And I'm going to go ahead and do this calculation in several steps. So I'm going to go ahead and hit enter. Then I'm going to go divided by, and I need to divide by 3, and then I need to divide by 3 again, and then I need to divide by 36. So I'm going to go ahead and I hit my divided by, and I'm going to go divided by 3, enter, divided by 3, enter, divided by 36, enter. And I'm coming up with 81.81 cubic yards. I think it'd be a good time to pause right now on this problem and just look back, see what we've done to this point. We wanted to figure out the volume, but we wanted to figure out the volume in cubic yards because that's how they sell the concrete, per cubic yard. So I took the diameter, which is 75 feet, and I divided it by 2 to get the radius, to get 37.5 feet. But then I needed to change that to yards. So I took 37.5 and divided that by 3. Then I looked at the thickness of the pad, which is actually the height of the cylinder, and it's given as 6 inches. And I need to divide that by 36 to change to yards. So when I multiply across here, I'm going to have yards squared times yards, which gives me yards cubed. Not done yet, because the question is, what is the cost what is the cost of the concrete? So I'm going to take my total number of cubic yards, and I'm going to multiply by the cost per cubic yard, which is 116.5. $116.50. So I'm going times 116.5, and I'm coming up with a value of $9,531.13. And we're home on this problem. So this problem, you just got to be careful with units. Be careful with units. All right, let's take a look at problem number 4. This is a probability problem, and it's actually a geometric probability problem because it involves area. And it asks you to find the probability that if you randomly select a point that's within the big circle, that point that you select would be within the little circle. So our procedure here is to find the area of the little circle, and divide that by the area of the big circle. Simple as that. And we want to express our answer as a fraction. So here we go. We're going to find the area of the little circle. So the area of the little circle would be pi r squared, which would be pi times the radius, which is 5 squared. Now, in the denominator, we'll find the area of the big circle. So here might be this tricky part. See, you need to understand that from the center out to the edge of the little circle is 5, and then from the edge of the little circle to the edge of the big circle is 7. So that means the radius for the big circle is 12. So when I go to find the area of the big circle, I'm going to use 12 for the radius. Now in this problem, when you have a pi on top and a pi on the bottom, those guys cancel. There's no need whatsoever to put that into your calculator. So I'm just do my arithmetic. On top I have 25. On the bottom I have 144. That cannot be simplified, and that makes it my answer. So the probability that you randomly select a point from within this big circle, that point is within the little circle, would be 25 out of 144. All right, let's look at number 5. You have a golf green. I'm not a golfer, but I'm sure that many of you are, or at least have been on a golf course. And the golf green is that area by the hole. And it says that the diameter here, the diameter across this golf green is 54 feet. That's what's given. And it says that this grass that makes up the golf green needs to be fertilized. And a gallon of fertilizer covers 400 square feet. And we're asked how many gallons are needed. So pretty much this involves finding the area of this golf green. So here's what I'm doing. I'll make my table: radius, diameter, circumference, and area. I am given the diameter. So the diameter is 54 feet. That makes the radius 27. And the area would be 27 squared times pi. So that would be 729 pi is the area. And you know what? I'm going to go ahead and take 729 and multiply it by pi. And I'm coming up with 2,290.22, and that would be square feet. So that's the area of this green. The problem says that 1 gallon of liquid fertilizer covers 400 square feet, and then it asks how many gallons. At this point, I'm looking at this as a division problem. So I'm going to take my total area, which is 2,290.22 square feet, and I'm going to divide that by 400 square feet per every gallon to figure out how many gallons I need. So I'm just going to go divided by 400, and I'm coming up with 5.73. And that's the answer to problem number 5. All right, let's take a look at number 6. This circle represents a carpet or a circular rug, if you will. And it says that the edge, now when it says edge, that kind of clues you or cues you that you're going to be dealing with the circumference here. It says the edge of the circular carpet needs surged. Now, if you're not familiar with this word surge or surged, it means they're going to just hem or finish the edge. So it'll have a finished look to it, and it'll prevent the carpet from fraying. So the cost is $3.25 per linear foot. If the total cost of serging the circumference of the carpet is $143, what is the area of the carpet? So I'm going to make my table: radius, diameter, circumference, and area. And ultimately, I have to figure out the area of the carpet. That's the question. Well, what do I know? I know that the cost is $3.25 per foot, and that the total cost is $143. So here's what I'm going to do. I'm going to take 143 and I'm going to divide that by $3.25 per foot to figure out how many feet. So in my calculator right now, I'm doing 143 divided by 3.25, and I'm coming up with 44 feet. Now let me pause and make sure you understand that. What this means is that the distance around this circle, which is the edge that has to be surged, has a total length of 44 feet. So my circumference is 44 feet. That makes the diameter 44. And it makes the radius 22. And the question is, what is the area of the carpet? So I'm going to do pi r squared. So I'm doing 22 squared, and that's going to give me 484 pi. It specifically asks us, however, to express our answer for the area to the nearest 0.01 square feet. So I'm going to do 484 times pi, and I'm coming up with 1520.53, and that's going to be square feet, and we're home. Let's run through this problem again. The problem did not directly give us the circumference, but it did give us enough information to figure out the circumference. We were told that every foot of surging cost $3.25, and the total cost was $143. So we took 143 divided by $3.25 per foot to figure out how many feet. And it turned out that it's 44 feet around this carpet. So the circumference is 44. That makes the diameter 44 and the radius 22. The area then would be 484 pi as a decimal, rounded to the nearest hundredth. Our answer would be 1,520.53 square feet. All right, number 7. Number 7 says, find the area of the circle. We know two things about this circle. We know the center is right here, and it has coordinates 14, 5, and we know a point that's on the circle. Well, in order to find the area, we kind of need to know the radius. So I'm going to draw in the radius first. So that's the radius right there. Then I'm going to let that radius be the hypotenuse of a right triangle. So I'm going to draw in a right triangle. Students, this is a Pythagorean theorem problem. I'm going to use a squared plus b squared equals c squared, except that instead of c squared, I'm going to have r squared. R is the hypotenuse. So left to right here, if I go from 14 to 20, that would be 6. Up and down, if I go from 5 to 13, that would be 8. Now, I know that the formula for the area of the circle is pi times the radius squared. So I know that if I do 6 squared plus 8 squared, that's going to give me r squared. So whatever this is right here is r squared, and that's the value I'm going to put in for r squared right there for the area. So this would be 100. It says express in terms of pi. So I don't need to multiply by pi. The pi is going along for the ride here. So this 100 right here, I'm going to substitute into my formula for r squared. So my answer then is going to be 100 pi. All right. Same procedure on problem number 8. It's the same kind of problem. The numbers are different. First thing I'm going to do is draw in a radius. Then I'm going to let the radius represent or be the hypotenuse of a right triangle. I'm going to find my two legs. If I go from -9 to 11, that would be 20. If I go from -31 up to -10, that would be 21. So I'm going to do Pythagorean theorem. I'd have 20 squared plus 21 squared equals r squared. So I'm going to do this calculation. 20 squared plus 21 squared turns out to be 841, and that equals r squared. Once again, I'd like to emphasize this point. I'm not really interested in figuring out what r is. If I wanted to know the value for r, I would take the square root of 841. But what I want to know is what r squared is, because it's r squared in the formula. So I'm just going to take this 841 and put it in right there for r squared, and I'll be done. So the answer would be 841 pi. All right, let's take a look at problem number 9. Same kind of problem. I'm going to draw in the radius here. This is r. Now, notice that the y-coordinate of the center point is -2, and the y-coordinate of the given point on the circle is also -2. So this is a horizontal line here. And if you go from -36 to -16, that would be 20. So the radius is 20. So if the radius is 20, then the radius squared would be 400. And that means the area of the circle would be 400 pi. And I'm done. So there you have it. There's your key to practice number 1. I'm hopeful, as always, that the video key and the accompanying explanation is something that helps you to understand how to do these problems. Thank you for your attention. You all have a great day.